product usually undergoes multiple stages like concept validation, functional testing, and small volume trial production before it hits the market. If every plastic part were made with a steel injection mold, the lead time would be long and the cost extremely high. Is there a more flexible and cost-effective solution? Welcome back to Zintilon's channel. Today, we're introducing a cost-efficient production process for low-volume plastic parts, vacuum casting. This process uses CNC machining or 3D printing to create an original master mold, then reproduces a silicone mold, and finally casts replicas identical to the master mold in a vacuum environment. Vacuum casting can accurately replicate textures and complex structures, support color matching for transparent materials, and verify the performance of various materials. How does vacuum casting work? Step 1. Create the original master mold. The quality of the master mold affects the precision and surface finish of the replicas, so it's necessary to choose the right process according to each part's needs. CNC machining is preferred if the part has high demands for tolerance, precision, surface gloss, or optical transparency, while 3D printing is a better option if the part has complex shapes, such as hollow structures, irregular cavities, or fine textures. In addition, secondary processing on the surface of the 3D printed master mold, like painting, sanding, or polishing, can achieve the final design effect. The subsequent silicone mold will fully replicate those details, ensuring the replica's surface matches the master mold closely. Step 2. Make the silicone mold. The silicone mold is the core bridge between the master mold and the replicas. Its production process requires strict control of key indicators like air bubbles and curing degree. Silicone casting and vacuum defoaming. Mix liquid silicone in proportion, usually 2-component silicone. The ratio must be strictly controlled to ensure curing effect. Pour it slowly around the master mold to ensure full coverage. Then place the mold box in a vacuum device to remove air bubbles from the silicone completely. Residual bubbles will cause depressions on the mold surface, directly affecting the replica quality. Curing. Put the defoamed mold box into a constant temperature oven at 40 degrees Celsius for curing. The curing time depends on the mold size, about 8 to 10 hours for small molds and 12 to 16 hours for large ones. Once the silicone is fully cured, disassemble the mold box, take out the rubber rods, and carefully remove the original master mold from the silicone. A cavity identical to the master mold will form then inside the silicone. The silicone mold is now ready. Step 3. Vacuum casting. Place the finished silicone mold in an oven and preheat it to 16 to 25 degrees Celsius according to the casting material's properties. Preheating keeps the silicone flexible, reduces the temperature difference between the casting material and the mold, and avoids shrinkage marks on the part. Meanwhile, evenly apply a special release agent to the inner wall of the mold cavity. This step is crucial to prevent the part from sticking to the mold. Uneven application may cause tear or mold marks on the part's surface. Choose the casting material based on the part's performance requirements. Heat the material to 40 degrees Celsius, stir it thoroughly, and immediately put it into a vacuum device for 50 to 60 seconds to further remove air bubbles. Slowly inject the pre-processed casting material into the silicone mold cavity in a vacuum environment. Once the cavity is fully filled, put the mold back into the 40 degrees Celsius oven for curing. After the material is fully cured, open the silicone mold, take out the formed part, and trim it slightly to get a qualified product. Low-volume production solution. For batch production, simply repeat the material pre-processing, casting, curing, demolding cycle. One silicone mold can usually be reused 15 to 20 times for low-volume production. Conclusion. In the entire vacuum casting process, standardized operations and parameter control directly determine the part quality. With rich practical experience, Zintilon's vacuum casting technicians can accurately control key parameters like temperature, vacuum degree, and curing time to ensure nearly perfect replication for each part. If you found this content helpful, please feel free to subscribe to our channel.